Hello everyone, welcome to our new recording. Today inshallah we will talk about the Synchrocheck function. So let us dive into the parameters and the definitions of the Synchrocheck functions and how we can test it using the OMICRON Test Universe software. As you can see here, is the wiring diagram of the Synchrocheck example, and this figure showing the wiring scheme of a practical example, but please note that the wiring L1, L2 is only as an example, so it can be a variant, it can be Y phase from the bus bar and so on. So as you can see from the wiring diagram here, or the wiring scheme, we have 3 line is inserted to the protection relay to represent the line voltage. Here is the L1, L2, L3, and the neutral. The secondary side of the voltage transformer of the line is connected to the analog input of the protection relay, and the bus bar voltage is connected as L1 and L2. But as we mentioned, L1, L2 here is just an example. For some schemes, most common schemes, it's using the Y phase to neutral from the bus bar VT, secondary side, to represent the bus bar voltage and to be able to test the Synchrocheck function. So in the main concept of the Synchrocheck or synchronizing electrical network, such as generator to the network, or network A to network B, or line to bus bar, it's only allowed within the very limited range of delta F and delta V and delta phi. Delta F represents the change of frequency, the difference of frequency. Delta V, the difference of the voltage between the line and the bus bar, or network A and network B, and delta phi is the phase angle differences between both sources. So for testing the Synchrocheck function, it's either done with the synchronizer test module or the quick CMC and state sequencer test module of the Test Universe software. So here you can see the network A and network B. So we have two VT. So the first one is simulating the network A, and the second one is simulating the network B. So we have VA frequency of source A and delta phi A. Also we have voltage of network B, frequency B, and delta phi B. And here is the Synchrocheck parameters, or Synchrocheck functions to check the delta V, the delta F, the delta phi. So the Synchrocheck, for physical reasons, synchronizing the electrical networks using this parameter settings, which is delta V and delta F and delta phi, and any mismatch of at least one of these three synchronizing conditions will lead to a damage in the substation. Here is the generic wiring of the Synchrocheck testing. Here is just an example. So the first test should be done is to check the synchro wiring check. You can test it using the quick CMC test modules. Different voltage at the inputs of the line and the inputs of the bus bar are checked in the relay HMI, or the display of the protection relay, just to make sure that the inputs are not swapped, the ratio of the VTs are correct, and the polarity also are correct. So let us start how to wire the synchro wiring check and how to test it using the quick CMC. So as you can see from our figures here, we injected the 3 line of the line voltage, 3 phase of the line voltage to be injected with the 3 phase of the CMC, and the fourth one, which is the reference voltage, can be used for injecting the L1 to L2 representing the bus voltage, or Y phase to neutral representing the bus bar voltage. And we need here two binary input. One of them is to simulate the Synchrocheck is okay, and the other one, which is binary input number 10 to binary input number 3, to represent that the circuit breaker close command is on. And also we need the binary output to simulate the Synchrocheck start. Okay. So the test object and the global hardware configuration need to be configured. So in the global hardware configuration, we have a general configuration of the CMC inputs, outputs should be done as I will explain. So for our test, we just have to select which signal we want to use and how this module should trigger them in the local hardware configuration in the next slide. Okay, here is the Synchrocheck parameters. As you can see, here is an example of the Synchrocheck parameters. So starting with the delta V, here is the maximum voltage difference allowed to make a Synchrocheck release, and as you can see here is equal to 2 volt. The second parameter is the maximum frequency difference, which is equal to 10 millihertz, and the maximum angle difference delta phi equal to 10 degree. And we have also another parameters for T minimum and T maximums. For the T maximum, called the maximum duration of the Synchrocheck, which equal to 100 seconds. We have also a synchro condition stability timer, which is 10 seconds, and we have external start and stop via the CMC binary input. And as you can see in the other graph here, we have the limits of the voltage to consider this line is live or dead, or the bus bar is live or dead, depends on this two values, V under and V over. So if the value is less than V under, the line or the bus bar can be considered as a switched off or dead. And if the voltage value exceeding or more than V greater, it means that the line or the bus bar is live. And we will explain a bit more about this graph in the next few slides. So here is the test cases. We can test it using the Synchrocheck function. So testing the logic and the parameters of the Synchrocheck functions requires many tests. And in this slide, we are going to present two tests, specifically test number 1 and test number 2A, as you can see from our screen in the commissioning situation. And but it's recommended to do all of this test. So for the test number 1, the different voltage are injected in the input of the line and the input of the bus bar, and we shall check in the display of the relay HMI if the inputs are swapped and if the ratios of the VT and polarity are correct. For the test 2A, 2B, 2C, 2D, and 2E, we will test the circuit breaker close authorization logic of the relay, and the logic makes its decision based on the actual voltage at the line and at the bus bar according to the logic table, as you can see on the right screen. So in this logic table, as we can explain, the line and the bus bar can be on and can be off. So depending on the actual voltage, the voltage present or absent alone is not enough to define it on or off. So to be on, the voltage must be over than the V greater value, and to be considered as off or dead has to be under this value V under. So any value in between is considered as an undefined. And here is a precaution need to be taken. So as we can see in the logic table, if one of the two sides of the circuit breaker is de-energized, so no circuit breaker close command release can be issued by the Synchrocheck function. However, this prevents the equipment that is switched off from being connected. For this reason, a Synchrocheck function can be bypassed when one side is switched off and the other side is switched on. So it can be bypassed when both sides are switched off as well. So in the case that both sides are on and define the Synchrocheck function, must compare both sides and look at the synchronization parameters, delta V, delta F, and delta phi, and take the decision. So the synchronism check is used to prevent any unauthorized equalizing current when switching on the circuit breaker, and this equalizing current for sure occur if the voltage on both sides of the circuit breakers are not the same. The frequency and the amplitude and the phase angle of the voltage are the criteria in our test. So only when all these factors are within the predefined boundaries for a specific time is the circuit breaker close command issued. This is tested in test number 3, tested number 4, 5. Okay, so in test number 3, we are testing the limits of the voltage amplitude difference. In test number 4, the limits of the voltage phase differences, and in test number 5, the limits of the frequency differences. So to ensure that the power network in both sides are stable, it's a good idea to wait a few seconds, which can be defined by T minimum. Okay, so T minimum here, we can test it, and we can make sure that both the power networks in both sides are stable. Okay, and with all conditions fulfilled before issue a circuit breaker close command. Okay, this is tested also in test number 6A. In case both sides never come to a synchronized state, we want the synchronization process to be aborted after a defined time. And this is important to avoid any unintended circuit breaker close command. And this can be called and can be tested in test number 6b, and can be called the T maximum or the duration time. So we have different parameters to check in all of this test. So the test case number 1, as we explained in the previous slide, we need to check the synchro wiring check, and we need to configure the global hardware configurations, test object, the local hardware configuration. So for our test here, we just have to select which signal we want to use and how the test module should trigger them in the local hardware configuration, as we will see in the next slides. So as you can see here, for our test, we need to configure the local hardware configuration. On the left side, we need to open the quick CMC module, and then click the hardware configuration, which is the local hardware configuration, and we can configure the voltage as shown in the right slide. So VL1 to earth, VL2 to earth, VL3 to earth for the line, and V1-1 for the bus bar voltage to check the wiring check. And here is the other slide for the binary input and binary output inside the local hardware configuration. So in the binary inputs, we need the signal circuit breaker close to be connected at binary input number 3, and the synchro OK or the Synchrocheck release signal at binary input number 10. So you can see here from the left side of the screen, we have the circuit breaker close, and we have also the synchro OK, which is connected to the binary input number 10. On the right side, we need a binary output, which called synchro start or Synchrocheck start to be connected at the binary output number 1 to start the process of the synchronization. And here, by using this test case number 1, we can test if the relay is wired correctly, or the VT ratios will configure based on the values appeared on the relay HMI. And the third part is the Synchrocheck function, calculating the delta V, the delta F, the delta phi correctly or not. So here is the first step to start with the wiring check of the Synchrocheck function. For the test case number 2a, we have a synchro voltage limits when the bus bar switched off. So in this test, from 2A up to 2E, we want to test the logic of the Synchrocheck and the limits of switched on and switched off. So in this test, we want to test the limits V under and V over in the bus bar when the line is switched on. So as you can see here in the right screen, we have the figure showing the Synchrocheck voltage limits V under and V over. So we will inject the nominal values of the line voltage to represent the line is live or on. And we will inject two values over the for the bus bar voltage to be over than the V under and under than the V under to simulate the bus bar voltage is on in the undefined region or in the dead status or off status. Okay. And for this test, we can use the test console module to test the voltage limits with the bus when the bus bar is switched off, and there is no need to change anything in the test object, or only the local hardware configuration has to be set as we explained in the test number 1. Okay, so for testing the test case number 2a by using the test console module, we have in the left screen here, we are simulating 4 stages. So the first one is called the pre-sync 1. Second state called the V bus bar over than the V under limit. Third state pre-sync number 2. And the fourth one to inject the bus bar voltage is less than the V under limits to be considered as dead or off. Okay, so we have a 4 states to be added, and it will be renamed as we explained. And the trigger options and the binary output can be shown in the right side of our screen, as you can see here. So the triggers for state number 1, it will be a time delay only, as you can see here, for 1 second. For the state number 2, it's the positive slope of the circuit breaker on signal, or it can wait for 7 seconds. And state number 3 is 1 second again for the pre-sync 2, state number 3. And state number 4, also we will inject 7 second, or it will be triggered using the circuit breaker on command. The analog outputs, as you can see from our screen, so state number 1, we have 0 voltage injected. On state number 2, the line will be simulated with the nominal voltage, but in the set mode, which is the line to line, here as you can see the bus bar is 12 volt in the state number 2. 12 volt is slightly over than the V under limit, so it will be considered as undefined, which means it's not live and it's not dead. Okay, in state number 3, the voltage is coming to 0 again for the line and bus bar to simulate the pre-sync 2. For the state number 4, we will inject the line with the nominal values, with the nominal voltage, and the bus bar to be slightly under the V under limit. So if we have the V under limit is 10 voltage, so we will inject 8 voltage to simulate that the bus bar is off or dead and the line is live. Okay, so the main difference between state number 2 and state number 4 right now, state number 2 simulating the line is live and the voltage is the nominal values, and the bus bar voltage is in the undefined region, which means it's not live and it's not dead. So the Synchrocheck release here is not expected, and the circuit breaker will not close. But in the state number 4 here, we have the voltage of the line is the nominal values, which means the line is live, but the bus bar is under the V under limit, which means, or lower than the V under limit, which means the bus bar considered as dead. So the Synchrocheck will be released and the circuit breaker on will be issued. And as you can see, here is the state configuration for state number 1, number 2, number 3, number 4, as we explained. So here is the Synchrocheck will start it, but it will not released, and the circuit breaker will not close because the bus bar voltage is in the undefined region. But in the state number 4 here, the Synchrocheck start, but the circuit breaker will be closed after predefined time, because the Synchrocheck is released based on the live line and dead bus test case. I will explain now different scenarios for the Synchrocheck, so you can test it using all our test cases as we explained. So the first one is the successful Synchrocheck. So let me explain it one by one. So as you can see, number 1 representing the start of the Synchrocheck function. So the start of this function can be done via external signal, which means binary input, or internal signals such as circuit breaker on command or the circuit breaker on signal. Okay, the line in number 2 representing the duration time. So the synchronizing device must verify all the parameters it's okay in this duration time. So after this time, the synchronizing device will be switched off the Synchrocheck and it will be aborted. Okay, so state number 3 in this successful Synchrocheck scenario representing the delta F, which means the difference of the frequency from the line and the bus bar, and this is a general sync condition, as well as also is in number 4, which is representing the delta V, number 5 representing the delta phi of the phase angles between the line and the voltage. Okay, so number 6, which is the waiting time, is a very important parameter because all the synchronizing condition should be checked to be stable during this time. So if everything is fine and the everything is stable, which means the synchronizing conditions are stable during this time, so the circuit breaker on signal it's possible and it will be issued in number 7. So we have also another parameters which called the Synchrocheck switch it off, and it will be on directly after the elapsed or the deactivation of the duration time, as you can see here the relation. So here is the first scenario of the successful Synchrocheck. We have also another scenarios which can be not successful due to the synchronizing condition is not stable. And when I said synchronizing condition, I mean delta V, delta F, and delta phi. So as you can see from our screen here, the Synchrocheck is started, and here is the duration time. Delta F was okay, delta V was okay, and then it changed to be not okay, which means it's not stable. So the synchronizing condition not stable because of the delta V, and the delta phi was okay. So the waiting time will be terminated here because the synchronizing condition is not stable due to delta V, and the circuit breaker will not be on, and the Synchrocheck release will not be issued. Okay, so in the line number 8 here is the Synchrocheck will be switched off or aborted after the elapsing of the waiting time. Okay, so here is the differences between the successful and unsuccessful synchro check, as you can see from our screen. So here is the main difference. Here is the delta V is not stable during the waiting time. Another example also which can be happened, which and we need to test during the synchrocheck function testing, which is the not successful scenario due to the duration time expired. So in our figure here, the synchrocheck is not successful because the duration time expired. So number one, representing the start of the function, as we said, via external signal, which means binary input, or via internal signal such as circuit breaker on command. Number two, representing the duration time. So the synchronizing device must verify all the parameters are okay in this time, and after this time the synchronizing device will switch off the synchrocheck function. Okay, number three here, the delta F was okay, delta V was not okay in number four during the waiting time, and number five, representing his delta phi was okay. Number six is the waiting time, so the synchronizing condition not okay during this waiting time, so the circuit breaker on command signal is not safe, and synchrocheck will not release. Okay, number seven, representing the circuit breaker on, which is not initiated due to the unsuccessful scenario during the waiting time. And after this waiting time, after the duration time, the synchronizing device will stop. Okay, so you can test all of these test cases, all of these scenarios as we explained. So let us return back to the test cases. So now we explained the test case number one, test case number 2A, which is the bus bar switched off and the line is healthy. And you can test also the test case number 2B, with the line is switched off. Test case number 2C, the bus bar is switched on. 2D, the line is switched on, which means the line is live. 2E, synchrocheck with the line and the bus bar will switch off, which means dead situation, and in most cases this dead situation is deactivated inside the relay configuration and inside the relay parameter setting. So we have three scenarios to be tested, which is a live line dead bus, or live bus dead line, or live line and live bus bar. But the dead line dead bus bar is not, in the most common cases, is not activated inside the relay configuration. Okay, test number three, we will check if both the line and the bus bar are live. We can check test number three with delta V, test number four with delta phi, test number five with delta F, and the test number six, it can be checked in all scenarios for checking the T minimum and checking the T maximum. So thank you everyone.